This video is going to look at convergent plate boundaries and the three different types that we find and where we can find each type around the world. Convergent plate boundaries happen when we have two plates that are colliding together. And just like we saw that divergent boundaries separate at about 5 centimeters per year, this is the same rate for convergent boundaries. Again, about the same rate that your fingernails grow. But it's going to be important to note what kind of plates are colliding at convergent boundaries, because depending on whether it's oceanic or continental crust, two things can happen. We can either have subduction zones develop or mountain building occur. Subduction zones develop when we have at least one oceanic plate involved. This plate, because it's denser, will be able to be pushed back into the earth, getting deeper over time. But we're going to see that in order for a subduction zone to occur, we need a denser piece of lithosphere in order to force it back into the earth. Generally, we see that it's our oceanic crust that subducts. Again, it's thinner, but it's denser. It's more easily pushed back into the earth. If we're looking at continental crust, because it's twice this thick and it's buoyant, it likes to float, it will never subduct. So we'll see that the exact type of plate boundary is going to depend on what type of plates are converging. We're going to see that there are three types for convergent plates. The first is oceanic continental, where an oceanic plate collides with a continental plate, like we see in the upper left part of that image. Here, because we have an oceanic plate involved, where it's denser, it's going to subduct underneath the continental plate. Our second type of convergent plate boundary is oceanic-oceanic. And here we have two thin, dense oceanic plates colliding. And so the older and therefore colder and denser oceanic plate will subduct beneath the newer oceanic plate, like we see in the middle left image. And the third type is continental-continental convergence. This is when two continents collide. But because both plates are so thick and so buoyant, we will not have subduction occur. Instead, we'll see mountain building processes. So for two out of these three, we have oceanic plates involved and therefore subduction zones. So if we want to quickly find these subduction zones in our oceans, what we need to look for are called deep ocean trenches. It's a topographic feature of our seafloor where it's these really long linear depressions. Think about a trench that you might have seen in an old war movie. So if we're looking for subduction, where we have an oceanic plate being pushed underneath a continental plate, all we need to look for on a map are deep ocean trenches. But we're going to go into each of these three types of convergent boundaries in more detail. We're going to start off with an oceanic-continental convergence. Here, because we have an oceanic plate colliding with a continental, that denser oceanic plate will subduct underneath the continent. But as that oceanic plate subducts deeper and deeper inside of the Earth, it's being subjected to higher temperatures. And once it reaches this really special depth of 100 kilometers deep, it's now deep enough in the Earth that that lithosphere is going to begin melting. It's going to start melting back into magma. And because we have liquid magma inside of a solid rock under a lot of pressure, it's going to start rising towards the surface, erupting as new volcanoes. And we call these lines of volcanoes that develop on top of a continent continental volcanic arcs. They form at a very specific location where that subducted oceanic lithosphere is melting, and all of that melted magma is rising straight up to the surface as a new chain of volcanoes, which again we call a continental volcanic arc. But if we have two oceanic plates converging, now we have to look at the ages of these two different plates. Because they're both oceanic, they're both thin and dense, whichever one is older will have more time to have cooled off and become even thinner and denser than a younger plate would be. But as the older plate subducts underneath the younger plate, the exact same thing will happen like we saw in the last slide. Once that subducted older plate reaches 100 kilometers in depth, it's going to be under enough heat and pressure to start melting back into magma. That magma is going to rise straight to the surface, creating a chain of volcanoes. But when this chain of volcanoes happens in our oceans, we call it a volcanic island arc. Same general process, but the location is different, so we give it a different name. And this is how the arc of volcanic islands forms off the coast of Alaska. But our final type of convergent boundary are continental. Remember, these are twice as thick as our oceanic plates are. So they're really buoyant. They like to float, and they cannot subduct back inside of a planet because they're just too thick. So when we have two continental plates that collide, instead of subducting, we're going to have mountain building occurring. These two plates are going to collide together and build up into the atmosphere. So we can see this happening on our planet today in India, where the Indian plate is colliding with Eurasia, creating the Himalayan mountains.